Cutting a while. It will say invalid input. All right. Let's go to Sumbo. Do you know what he's gonna say?
It will say male because
Okay.
of the chat
Okay.
at the
Goswell, do you know what this is gonna say? What's gonna be the output? Goswell, you're muted. I don't know if you're saying anything. Okay. All right. So maybe his network is not working well. By the way, Obi was supposed to be here, but he sent me a text that his network is having issues, so that's why it's not here. All right. So then I have one more person. Oh, this guy is not here as well. Okay. I think he also left. Okay. So I'm gonna run it now, and let's see what's gonna happen. So I push enter, and it says you are male. All right. So what probably happened here? So Sumba said he was going to say you're male. Sumba, can you explain what's going on here?
um cost you star at in bracket zero.
So what does
That
chat do?
means it's going to take the first letter of whatever the input is, and that's what it's going to read. So because the input was Malam and there is a male case there, so it's taking the first letter of which is the M. If you type Collins, it will say invalid. But because it's taking the first letter which is the M, that's why it gives you the response as well.
All right, good. So that's correct. That's correct. So what you're actually doing here when you use chat, you're saying, remember, your input is getting a string. Anything you type into the computer is a string. That's first. Anything you give from this command prompt is always a string. So you are the one that have to convert it to the data type you want. But in this case, you want to convert what the person is typing to a char. You want to use a char, and you use this char art. And basically, what char art does is char art takes a string and says, uh, when you put the number here, it says you're actually saying, give me the first letter of whatever the person typed. That's what you're doing with this char art. So even if I typed hello, sorry, let's run that again. If I typed hello world, say even with space, gibberish, all of this, what this chat art is doing is saying, just give me only this first letter. Give me the first letter, or give me the character that is found in the first index. And that's exactly what it gives you. It gives you H back. And then in this case, if I press enter, because there's no H here, it's going to give us the invalid stuff because H is not in this subset. Now, I'm going to break this down even more as we go on, but I just want you guys to know that's what's happening here. Then also, there is another way because this is a very interesting way that also made sure that whether the person, it doesn't matter if the person types in an uppercase letter or a smaller case letter or lowercase letter, it will give you the right response. So if you type a capital F or a small f, it's going to give you a good response. This is a very nice solution. It's actually a way to make sure that your software is very friendly. It doesn't it's case insensitive. That's probably how you say that. But there is also a nicer an even an easier way to do it, and I'd like to show you guys that. So one way you could do it is um or does anyone have a question first about the chat stuff I explained? Do you guys understand it? If you understand it, please raise your hands. Okay. All right. Great, great. So since you guys understand it, if I did something like this now, I said I change char at 3. So I say, get me char at 3, and I run this, and I type beam ball. Uh, I say beam. Oh no, beam ball. So what's gonna happen? What's this gonna give me? Constance? Chinonso?
Since 3 is the number B, so it's going to give invalid input
And how is it? How do you know that 3 is number B? How did you count it?
from 0, 0, 1 to
Exactly.
3.
So this is the index space. So it starts counting from 0. So the first B is index 0. So this is an index pointer. You're actually saying give me the character at this index. So you actually say this is going to be 0, 1, 2, 3. So bimbo here is going to be what is going to go into this gender. So if we run it now, if we I mean, if I push enter, it's going to say invalid input. But if I say beam, let's try it again. If I use a different input and I say beam full, what's this going to give us? Constance?
3. It's gonna give you a
Exactly,
female.
because if you count the index space, 0, 1, 2, 3 is going to be F, and the F is going to be here. So it's going to say you're a female. So that's what this chat is doing. So it's good you guys figured out. So of course your solution was good. You say give me the first letter. I don't care about the rest. So I was also saying there's also an easier way to do it. So you don't have to use case M and two different cases like this. And can anyone give I'll give 1 minute. Can anyone give a suggestion on how let me go back on how we can solve it without expressing two different cases like this, but it will still be case insensitive? Students, are you raising your hand? Okay, so you want to tell us?
Yeah,
All right, let's go.
I think you can convert to uppercase or to
Exactly.
lowercase.
So that would be the right solution to that. So, or not, this is also the right solution, but that would be a much more nicer solution. So I would just convert it to lowercase and I would just come here, just say dot to think in Java. Oh, just a minute, just a minute. We can do that at this point. Okay, let's do that at this point. We'll say dot to lowercase. And then, so we get what the user typed in, we convert it to lowercase, and we take the first character. So let's try this out. So I'll say, what's your gender? I'll use a capital M. It says you're a male. If we run it again, if it says what's your gender, I would say small letter M, and it says you're male. So that way it's in case insensitive. So please take a good look at it. What I did, you can also break this up if you want. So let's break this up. So because for some people it's like, huh, this dot 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 is always confusing for me. I don't even know what's doing. So let's break it up. So first we're gonna convert. We're gonna bring this down here and let's break it up so it looks a little bit more easier to read. So we're gonna say the first one is a string, and this string is we're gonna say call it what the user entered. So that's gonna be this guy, scanner, right? This is what the user entered. Then we create another string and we say we converted to lower case. And to convert that now you say what the user entered dot to lower case. And then the next one will now be our gender where we say we We converted to lowercase. We now say what we converted to lowercase, give us the first character of it. So if you want to break it down so you understand what is, you can do it this way. So the first thing is you got what the user entered, you put it in the variable, what the user entered. You took this variable that's what the user entered, you now turned it to lowercase, the answer of it, you put it in we convert it to lowercase, and then you take this variable, we convert it to lowercase, and then you pick the first character in it, and it gives you gender. And if you run it, it gives you the same thing. So you say male. So that is slightly what we can do with that. But of course, when you start programming, you don't need to do it like this. You just it's just best you do it. It's just best you do it the way we did it before, everything together. But yeah, you can always break it down if it's confusing for you, so you know what it's doing. Oh, so is there do you guys have any questions relating to this? Any question? All right, good, no question. So beautiful. So, but in all, I think the case statement, the switch case is going to be something you guys will play around with a lot, and it's good to see that you guys kind of, in my opinion, you guys mastered it. All right, let's go to more interesting things we'll be having this week. So there are some terms I want to get you guys acquainted with. We've already been playing with them, but it's always a good thing for you to know what they are. I want to use the right names for them. And what we'll be looking at now are operators. Some of these operators you probably have heard about them in math, or if not in math, if you just think about it, you know that okay, this is probably what it means. So we have different kinds of operators. Operators are basically symbols that we use to do things, and we're going to see more of them as we go. But I just want to give a quick overview of them. So we have, and actually, operators are actually symbols that perform operations on variables and values. So the plus, the minus, all the stuff. So I'm going to introduce you guys to all the operators, or almost all the operators that exist in Java. So to break them down or to group them, the first we have the arithmetic operator, assignment operator, relational operator, logical operators, unary operators, and bitwise operators. Now let's go down one by one and see what they are. You understand? Get familiar with these names. So the first one, arithmetic operators. Like the word says, arithmetic. This is a math term. I'm sure you guys are in school. Oh, it's time for arithmetic. It just means basic, plus, minus, multiplication, division, modulo, right? So you've been using that a lot already during the programming when you did 1 plus 2. What is I told you guys to calculate if someone was older than so, or giving birth to this and that, and you guys used plus a lot. You guys use minus, you guys use times, or you can also use times. And the arithmetic operator for division is is this guy here, the slash. So if you were to divide something, so I'm just gonna clear this out so I can just show. So I'm just gonna say system.out.print. So if I said 3, if I said 4 divided by 2, and if I run this, it will give you 2. So this is the arithmetic operator for division. Just like you guys have multiplication, I think this is for multiplication is the asterisk. When you do that, it gives you 4 times 2 and all of that. So this is basic and all of that. The one I'm not sure if you guys are familiar with is the modulo. Who does not know what this modulo is and who has not used it before? Raise your hands, please, if you've not used modulo or you don't know what it does. So if like, what would be the answer of this? So first of all, I think I'm asking too much questions at the same time. Who does not know what modulo is? Raise up your hand. So Sumba's hand is up. Chinonso hand is up. Right? Okay. And Goswell's hand is up. Good. So I'm now gonna ask those that know. So Constance, what will be the result of this if I run it? Okay.
It
And
will
why
be
would it be
zero
0?
because the modulo it gives you basically divides and then gives you the remainder. So 4 divided by 2 is what, two remaining
Exactly.
zeros. So the
So
answer would be zero.
modulo just gives you the remainder of a division. If the remainder is not, it just gives you exactly the remainder. That's it. So if I did 7 modulo 2, so Gospel, what will 7 modulo 2 give us based on the explanation I gave?
Okay.
Just run it
I
and
think
check.
that will be one.
And you see that is 1. So modulo gives you the remainder. That's what it does. So while if you want to get the division of something, you use the slash, which gives you the division, the exact division. But modulo would divide and then give you the remainder. The remainder is what your result will be. Okay, very powerful thing. It looks like, huh? What would I need this for? But we're gonna see. We're gonna have some exercises where we're gonna play with this modulo, and you're like, oh my god, this stuff is really powerful. So these are arithmetic operators. You guys know about them. You've been using them since you were kids. It's very popular, except probably this modulo now that just came in. Modulo is also in arithmetic and math. It's just I think when we were younger, teachers didn't really use it that much. But I have solved problems with it when I was younger in math. Only I just didn't know what it was, or I forgot it immediately. So it is there. It's a powerful it's a very powerful operator that you can use to solve some problems that look complex but are easy to solve using modulo. Chino, so your hands are up. Your hands up. Oh, okay.
Oh, I
So
think
we'll
it's
go to
from
the
the
next
previous
one. We
time.
have assignment operators. Of course, you guys have been using assignment operators since we've been working, right? So you see assignment operators. Look at just think of the word. The word means assign. You want to assign something to something. Anytime you want to assign something to something, you call that, or something to another thing, you call that assignment operators. And the assignment operators we've been using so far is the equal sign. So you see, when you say A is equal to B, you're assigning B, like this one here, you're assigning the value in B into A. That's what it is. So you're assigning. When you did plus equal to a number, you're saying take A, add it to B, and assign the answer back to A. If you also use minus equal to, you're saying take A, subtract what is in A with B, and the answer of that, assign it back to A. And we go on and on. The same thing with the modulo. You take a value, you say A, take A, solve the modulo of A and B, and take the answer of that and put it back to A. So you see, you're constantly assigning. And like I showed you guys last time, it's also equivalent to writing it out like this by saying, take A is equal to A modulo B, and the answer, assign it back to A. You get it? So these are assignment operators. The equal to sign is an assignment operators. Plus equal to, minus equal to, times equal to. Very handy stuff. They are called assignment operators. So use don't I don't think you just need to cram it. Just think of the word. Oh, I want to assign something to something. Okay. Anytime I use a symbol that assigns something, that's an assignment operator. So it's good you know the term. Just have it in mind. Then we have relational operator. Relational operators are used to compare, and we've been playing around with it a lot. One of the relational operators we've been playing around with is the equal to. Is A equal to B? We use the double equal sign. So you see, when you do 3 equal to 5, what you're saying is 3 the same as 5? It returns false because they're not the same. Then we have the not equal to sign. So the not equal to sign will return true if the left and the right side are actually not the same. So you see, if you had an expression where you said is 3 not equal to 5, it will return true. So let's look at that. So if I had an if statement here, I say if, let me say string symbol is equal to symbol. Sorry, string is capital. I'm going to duplicate this and I'll say string dal is equal to Darlington. And I said, and I'll do something like this. Symbol is not equal to dal. So what would be the response of this? Symbol, tell me, what do you think will be the will this what would this expression print out? Sorry?
True.
All right, let's give it a try.
True.
It says true indeed, because symbol is indeed not the same as Darlington. But if I said equal, what would this print out? Constance, what would this print out? False, of course, because symbol and Darlington are not the same
False.
string. So if I run it, of course, it says false. And on and on. I think this makes a lot of sense. Then we have the greater than symbol, which we already used before. So if you said is 3 greater than is 3 greater than 4, this will print a false because 3 is not greater than 4. So let's run that. See, it prints false because 3 is not greater than 4. So these are all the operators we know. This is greater than or equal to, less than or equal to. So these are called relational operator. And to me, how I think about it is, okay, you say two things. How do they relate? The left side and the right side. How do they relate? Are they relating? Are they not relating? Give it true or false if they are or if they're not. So these are called relational operators. The next one are the logical operators. So the three logical operators we have is, at least the three popular logical operators we have are the and, the or, and the not. So let's give that a try. So what if I wanted to check if something, so let's see, I'm gonna ask you guys now. So who's gonna help me out here? So uh let me see. Let me create a string. I'm gonna call it I'm gonna create an integer. My integer is gonna be no length age is equal to 3. And then create another int, and I'll say uh, Ellie Ellie age is equal to 6. So, and then I'll say, let me see, int passing score, passing age, or let me say swim age. And another thing, I'm gonna add another one. I'll say, I'll create a char. I'll say Nolan's gender is equal to M, and I'll just do another one. Uh, female, I say Ellie gender. All right, so we have a couple of variables here. So we have the first variable is the gender of Nolan, which is M. Ellie's gender is F. Nolan's age is 3, and Ellie's age is 6. Now, I want to write an if statement that checks if Nolan is a male and is older than 5 years. So let me write here. Check if Nolan is a male and older than 5 years. So who's gonna help me? What am I gonna write here in my if statement? So let's go. Let me see. So who volunteer first of all? Who would like to volunteer to solve this? Anyone apart from Ifeanyi? No Ifeanyi yet. Ifeanyi, wait a bit. All right. So Constance, what am I gonna write here? So you Oh, whoa, 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 whoa. Constance, Constance, you have to stop first
Yeah.
because you're also programming for a while.
If
So let's give Chinonso a try
oh,
because Chinonso is probably not as good as you yet, or almost as good as you. So Chinonso, give us a try. I'm curious.
Um,
Uh
to
huh.
check if
You
Nolan
dictate, I'll
is
type.
male, you can say if, yeah, you say um
Nolan equal
Nolan
to like
equal
this.
to Nolan, yeah, Nolan equal,
Okay.
or
Like this.
Nolan
Okay.
gender equal to, oh,
Okay.
I think the equal to has to be two, equal
M.
to
Okay. M
M,
like this.
no, capital M. Okay, yeah, I think I'm not getting to. Um, if Nolan gender equal to M, then I don't know why it's not coming out well. The M has to
A
be
single
like
quote.
in
Okay.
quotation in the char.
Okay.
Yeah,
Okay. Go on.
single quotes.
That's it.
And then the
Okay.
it's underlined, so I don't know why. But then
Inside
you move
HDB.
out of it and write. Then
Okay.
you can write yeah, system dot out
I can just say aloud.
dot print line.
Okay. So, but
Then
what
quote.
about this other part?
Yeah.
An older than 5 years.
Oh, okay. Then after the M, you can put after the char M. Then you can put
Colon like this.
colon.
Like this one.
No, the dot.
That's good. Just try.
Oh, okay. I don't know what to do.
Okay.
I
Okay.
don't know
Just
which
hold
one to
that
put.
thought.
Is that this one? I think it's this one then. Oh no, you put line.
And
Is
okay.
it all that you said? And okay, put and signed.
Oh, okay. Like this.
No, not the sign. The and the short form of
Oh,
and.
oh, two. Okay. Okay.
Yeah,
Uh huh.
two. I think it's two. And yeah, and what's the second question? If Nolan is male and older than 5, and then age, Nolan age greater
All right. Good job. Good
than
job.
5.
Good job. So let's run it to see. It will say, of course, we did not print an else. So if we printed an else here, it will say system the print. No. So this is actually good. This is the solution to that. And what I wanted you to practice was the double and. So of course you could be like, oh, I can do another if else or something. No, I don't even think you can do that, but you can put another if inside the if block and say, okay, if this is true, I'll put another if here, and then I'll check if Nolan's age is 5, like that. This is kind of ugly code. Because, of course, you can do it like that. It will still give you the same answer. So if I did something like this, and I put this in here, I create another if inside the if, and put this stuff here. So if I get this out of here, so if I made Nolan now 5 years old, or 6, let me make it 6 because we said greater than. So if I run this, it will still work. It will still say allowed, but this is ugly code because you can take this stuff and put it in the same if, which is what we did. So that's where you can use your logical operator. So you see, we solved all of that in this line. So you said
Operators.
Nolan's gender is equal to male and Nolan's age is 5. Then you do this. So that's what this logical operators are. Remember, I was playing around with Chinon, so I was typing the word and. But she was like, no, we have to use the operator, the one that C sharp understand. I mean, the one that Java understands, which is this double. sign. So you have to use that. This is what it means. Double ampersand is actually the logical and. The double line, I don't know what you call this, double stroke or double line, that is the logical or. So if we could say if he's a male or, so if I said or, if I say if Nolan is male or greater than 5 allowed. So you see this changes the logic because at this stage now Nolan is just 3 years old. But if I run this, it will still say allowed because one of these two places, two sides must be true for this to pass. So if I run this now, you see it will say allowed because Nolan is male and it doesn't matter that he is not above 5. So that is the logical or it's the same thing. Just think about it logically. If are we eating, we are going to eat rice or beans. So any of the two will do. But if you say we're going to eat rice and beans, that means both of them have to be in the soup or needs to be in the food. But if you say rice or beans, as long as one of them is true, your your condition passes. Then the exclamation sign is the logical not. So if you say, "Oh, um, check if Nolan is not a female," so I'm gonna change this. If I say, "Okay, I want you to check if Nolan's gender is not equal to M." So when you use the exclamation mark, is a negation. It's like is the logical not sign. So this is how you do that. You say if Nolan is not equal to, in this case, one equal to male, or I'm going to put female this time, then allow. So you see, when we run this now, it's going to say allowed. And if I change this to M, which is check if Nolan is not male, which means you are saying Nolan should be female or should be anything but a male, allowed. Then when I run this now, it's going to say um, nope, because this does not pass because Nolan's gender is actually male. But you want it to check, it should only give you true when it's not male. So if you think about it logically too, that's how it works. That's how you think about it. You say, oh, give me anything that is not, uh, I want to eat anything that is not rice. So that means the person can give you every other thing, but just not rice. So that's how you have to think about it. That's those are the logical operators. So these are the three powerful ones, the three most popular ones, the and, the or, and the not. So please look at how you write them. Then the next one I want to look at is the unary operator. The unary operator are the ones you use for to do your um uh what do you call it? To like we've used the ones for increment. Um the normal one is for plus because you know this plus we use it in two different ways. So sometimes we use it to concatenate. So that's not the one we're talking about. So if I said allow, here I'm printing allowed and I do plus hello. If I do something like this, so at this plus here is not a unary operator. This is what this is doing is concatenating, is adding two strings. So this is not the same as this unary operators. The unary operators we're talking about here is used to really do, additions and all of that. So let's see if we run this. Now you see it prints. Let me make this to change this to an F. So if we run this, you see it just concatenates allowed hello. So we have this one as well, increment, decrement, and this is a logical complement. This is also an inversion. So if I what this, you can also use this. Yeah, it's also kind of not. So if I had a boolean here that says, um, I'll say boolean happy, I'll say is happy, and I say happy is false. So I can come down here and say only print this when the person is not happy, right? I could say only print this aloud hello if the person is not happy. So how do I do that? I can just do exclamation mark and I say is happy. So what this does is, as you can see here, is a logical complement operator. It inverts the value of a boolean. So that means this will only be true if this is happy is false. Does that make sense? So what this is going to do is it will be this if statement will be true if this is happy is false. Just because of you put this inversion here. So if we run this now, it's going to say allow hello because is happy is false. Because what you're testing here is you're saying print or go into this if the value in happy is the opposite or is false. If I turn this to true now, then what you're saying now is, um, let me see. Let's run this and see what it's gonna do. It's gonna say nope because it's the inversion of this. Oh, sorry. Yeah, because the invert of true is false, and because of it's false, that means if the if statement is not gonna pass, and because remember the if statement only passes if whatever value you 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 evaluate in here, it must always be true. If it's not true, it's going to go to else. So since is happy is true, and you use this exclamation mark to invert it, that means the answer of this will now be false. All right, let me bring this out so you guys will see it how it really looks like. So I'm going to create another boolean. I'm going to call this result of is happy. I'm going to paste it here. So this will help you see exactly what's going on here. So I'm going to remove this is happy and I'm going to put here result of is happy. So let's put a breakpoint here. Then I'm going to run this in debug mode so you see what's going on. So you see, if I put my mouse here, you see is happy at this point is what? It's true. And then when we came here, we say we want you to invert, to change this is happy with this exclamation mark, invert it. So if we step over, we'll see now that the is happy is now what? False. Because we inverted is happy and took the result and put it in a new variable called result of is happy. And you see the inverted is happy is false. Because it takes whatever is in happy and it turns it to the opposite. And then when you come here and you say if the result of is happy is false, you say if false, if now you're saying if result, and remember this if statement only will go inside if the answer is true. But you see its result is already false. So that means it's not going to go in there, it's just going to go to the else. So when we run all of this now, you see it does print out nope because that's what we have in our else statement. So two things to remember: your if operator, the if operator only goes in if the result of whatever it evaluates returns a true. If it returns a false, it's not going to go in there. It's going to go to the next place. So that's why when it checked this guy was false. So it's not going to go in here because it only evaluates to true. So you can shorthand all of this by just taking this is happy and putting it in here. And what it's just saying is check is happy. If the result of this is happy is true, go in. If it's not, come in. And when it checked the results, it saw is happy is true and it inverted it. That means the result will now be false. It means else. But if I change this to true to false now, when it inverts it now, it's going to be true because the invert of false is true. Then it goes to allow hello. Then, then we can see that when we print that, it gives us this. So this is an operator you find a lot in a lot of people's code. When you're looking at codes, just know what it's doing. It takes the value, the true or false value that is in there, and it inverts it. It just changes to the opposite. And when it changes to the opposite, that will become the new value. Is there any questions? You guys understand this? If you don't understand it, please raise up your hand. All right, great. So I see everyone is following. So the decrementer, I see you guys have used this before. It just takes the value and decreases it by one. The plus, it takes the value and increments it by one. This is just a minus operator. This is a plus operator. Then we'll go to the next one, which is the bitwise. The bitwise, I'm not going to spend too much time on this one because you don't get to use this a lot. I have never used this since my career started. There are some cases though, especially when you're programming things for hardware, or you're really programming something that has to really, like you're programming a microchip or something like that. Yes, you might have to play with bitwise. What bitwise operators are used for is they are actually used to perform specific operations on bits or binary values. So you know binary 01010101, all this kind of stuff. So if you want to like perform operation on that level of calculation. Like you have a binary value and you want to perform operations, you want to add two binaries together, you use the bitwise operator. So I'm not going to spend too much time on it. I don't even want to talk about it too much, but I just want to show you guys that it is there. And this is how they look like. So this is a bitwise complement, the left shift, because when you have 010101 like that, sometimes you have to shift the bits to the left or you have to shift the bits to the right in terms when you're performing a calculation. And this is a bitwise and a bitwise exclusive OR. So these are there. You don't have to bother about it. I've not used it ever since I've been programming for now over 20 years or so. So, but it's good to know it's there. It's part of what the software can do. So you might work for a company that really wants you guys uh, to manipulate data on binary on a binary level. Then most likely you guys will be doing stuff using bitwise. Great. And I want to also introduce you guys to ternary operators. A lot of you might have seen this, but not know that that's what it's called, ternary operators. So ternary operators are operators or conditional operators that you can use to write if-else statements in a very short way. I think it's a very good thing to know and recognize because you would see it a lot in people's codes. So you use this operator or this way of writing an if-else statement when you are only checking for just two conditions. You're saying if is a male, then is a female. You cannot use it when you are saying if this is this, else this is this, else this is this, else. No, you cannot have that next as if else. That's not what this is. The ternary operator would do for you. It only checks if something is true, it will print one side. If something is false, it print the other side. And how does it look like? So you see, this is just the blueprint. So if you have a variable here, you have an expression, and the expression, if the expression is true, it will give you what's on the first side of the expression, and if it's false, it will give you what's on the other side of the expression. And look at the symbols that we're using to break this apart. You're using the question mark, and we're using the semicolon. Now let's look at it in real life. So here we see we have a string called results, and you have a variable called mark. The mark is probably written somewhere else. Now, normally you can use a okay. Let's break this out using an if else statement. So what you're doing is you're checking if someone's mark is above 40, you give the person a pass. If not, you give the person a fail. Let's write this in an if else statement. I'm gonna clear this out. So we're gonna call this uh who we're gonna use now. We're gonna use Constance. We're gonna say int Constance score. So this is a variable that's gonna hold Constance score for her exam, and Constance scored 40. Right now, what we want to check is we want to let people know if they passed or failed. Right. So we have an if statement that says, okay, if Constance score is greater than 40, or we're gonna say greater than 50, that means Constance, we can now print Constance passed. I'll say Windows print passed. And we now have the else. We now say if, that means if the person is not, if the score was not above 50, we're going to now say we're going to print out failed, right? So we're going to say failed. Now it's very obvious. You guys have been playing with if else. It's very obvious what this is going to print out. So let's do that. You see Constance failed because her score was just 40. Whereas if Constance scored 60 and we run this again, we'll say it's going to print pass. This is an if else statement you guys know. Now, the interesting thing about ternary operator is you can write all of this in one line using the ternary operator. Very interesting. So we're going to comment this out now, and we're going to write this same thing using a ternary operator. So all you have to do is you're gonna say, we're gonna do something like this. We're gonna say, um, we're gonna say constants. We can just put that in bracket. Let's just make it look good. Constant score greater than 50, and then here you put a question mark because this is how you're saying, okay, this is a ternary operator. If this is true, the first part always prints if this is true. So if this evaluation is true, it will print the first part, and if it's not true, it will print the part that is at the end here. So the first part of this is constants passed, so I'm going to print that here, and the second part is constants failed. We're going to print that here, and you see what is separating it is a semicolon, right? Let's see what is breaking here. Not a statement. Okay, great. Okay, let's do it. So it's saying that it's not a statement because it's supposed to return something. So let's do that in a different way where we say string. We're gonna say string is result is equal to. So we are not gonna print it directly out. We're just gonna store the answer or what we want to say. We're just gonna store it out here. So that way it's going to take whatever it is and store it in our result. And then we just have only one print statement under, and we now print our result. So if we get rid of this now, see, it makes a lot of sense. So if we run this now, we'll see that it's going to print passed, but if Constance scored 40, run this now, it's going to print failed. And this is the same thing as that if else statement, but look at how short it is. Look at just one line, we solved all of that problem. So again, what you normally put in your if block, you put it in here. You don't have to put a bracket there. I normally put brackets because it makes it readable. So you can also do it like this. It will run. You can even do your and here. You can say and like also did, and age is greater than 15. So if we had an age here, int age is equal to 30. So you can even do that. So if we run this, it says failed. So what it's actually doing is it's going to check if this whole expression is true. If this whole expression is true, it will give you passed. If this whole expression is false, or the evaluation of this whole expression is false, it will give you failed. So in this case, we see that constant score was not greater than 50, so it just goes to failed. So of course you can also put a bracket to make it readable. I normally like to do that. So that's what ternary operators are. So please, the syntax is important. You write your evaluation, the expression you want to evaluate. You put a question mark. You put the first result that you want it to do if it's true. You put the second one if that you want if it's false. And it doesn't matter what data type you're returning. You can also say I don't want to return string. I want it to be an int. That's also possible, but that means you have to return int here. So you have to change this to maybe you say 45. Maybe this one will now be 50. So it's still an if statement, and you're taking the value, you're storing it in an int. You can also make it a char. If it's a char you want to return, you say, okay, my result is going to be a char. And then when you evaluate this, you say, when you evaluate it, what I want to return is an M, and what I want to return is or an F. And it takes either of this and it stores it in this result. So it doesn't matter the data type you want, you use it, you do your tests, your evaluation, and you return the data type you want as a response. And then you can do whatever you want with it. So this is what you call the ternary operator. You would see that very often in code. I use that a lot in my programming career. So it's just a shorthand for writing if else statements. That's just it. Um, I want to give you guys one to play with. So I want you guys to just take 5 minutes to write a ternary operator for this. So convert this code or rewrite it using this ternary operator I just showed you guys. So I'm gonna post it in the chat as well. So let me see. Um, use ternary operator. So please, shoot, I'm gonna give you guys uh 10 minutes. So I'm gonna put a timer for 10 minutes. All right. So you guys can go. I'm gonna I'm gonna not block the screen so you guys can see the screen. Pull more focus. So let's see. So I'll say 10 minutes. Let me see. Journey, what am I gonna do? Oh, I can't even manipulate this, guys. Oh, let me see. Oh, my bad. I don't think I can even manipulate the time here. Oh, it's okay. Let's just do a short break and I'll restart it when it turns. I'll take the timer away so it doesn't make you guys nervous. Okay, so let's take a look at what you guys have done. So I'm just gonna pick out someone to share their screen. Um, Constance, were you able to solve it? Constance, can you hear me? Oh, oh, we can't hear you guys. All right, so let's try to solve the problem. Constance, were you able to solve it? Okay, can you share your screen and show us what you did?
Yes, I was. Okay.
All right, that's good. That's good. So, what about so were you able to do that?
Thank you.
Okay, was it similar to what Constance did? Okay, and
Oh
Ifine, were you
yeah,
able to do the same?
yeah, very just
Okay,
exactly
Zumba,
what
what
she
about
did.
you? All
Yeah,
right,
I've done it.
Boswell, what about you? Okay, all right, that's good. So let's go back because
Yes, done it.
gradually we're coming to where things will start getting interesting. But we have to go through all of this to for me to usher you guys into much more interesting things. Now, the next part I also want to let you guys know about is the automatic converters, or I mean, converters, the automatic converter and the explicit converters or conversions. These are something you guys have already been doing, but probably you guys didn't know. So we had situations, for example, where, yeah. So first of all, let me explain what the conversions are. So if you remember in one of our courses, I showed you guys the different data types, right? So if we scroll up, let me see if I can find that screen again where I showed you guys the types, various data types. Yeah, that is this guys, right? So if you look at these data types, the byte, the short, the int, the long, the float, the double, right? All of these data types, I would say the first one, two, no, yeah, first one, two, three, four, five, six. The first six data types are data types we use to store numbers, right? So on this side of the screen, you see we have whole numbers, the bytes, the short, the int, the long, and the floating numbers are the float and the double. Correct? Do you guys still remember this? Raise up your hand if you remember, or if you were here in the class for that. Okay, so Tinosa remembers, Constance remembers, and I'm sure Ifan you remember as well, right? Sumba, your hands are still up. Yeah, great. So type conversion is converting one data type to another. So we're going to focus now on the number type, right? Now, what if, so we see now the byte data type is just between minus 128 to 127 bytes, numbers, that's what it can hold. What if you have an integer that is 1000 and you try to store it in bytes? Is that going to work? Is it going to fit in? What do you guys think? Chinonso, your hands up. Okay, Constance, your hands was also up. You have something to say about it?
That that wouldn't work.
You said probably what?
Yeah, it'd probably show an error because it's too big.
Exactly. But that's what we think logically is going to happen.
It would
But
probably show an error
Java
because it's,
is
it's too
letting us
big
know
to
that
fit in
we
there.
can actually do that. You understand? So we can convert forward or we can convert backwards. Converting backward is a lot difficult because converting backward is the example I just gave. We have a longer number I want to put into something smaller. That's kind of more difficult. But converting forward is a lot easier because if you have 127 and you want to put it in ints, that's not a problem, right? It's just like you're saying you have one jug of water, but you want to put it in a drum. So if you have one jug of water, there's no problem with putting it in a drum because the drum is bigger. It will stay in the drum. It's going to work. But if you have a drum of water and you want to put it in a jug, it's going to overflow. It's going to pour out. I mean, it cannot fit. But the point is, Java gives you an opportunity to still convert because sometimes you might be storing something very small in a big drum. So if you had an integer that had the number 4, like an age is like 20, and you stored it in an int, yes, you can take that's 34. Like if it's the age is 34, you can take that 34 and store it in a bytes because it will fit. Because even though it's a large drum, you can still put the data. So let's see how that works. So we're going to talk about, first of all, I'm going to show you guys an example of converting forward, which is quite easy. So we have an integer. So we're going to say we have let's start with a byte. So we have a byte of 124. Sorry, a byte called byte data. And the byte data, the value is 124. And we want to store it in an int called int data. So how do we do that? Now we can do that easily by just typing it. You see the conversion works, and that's why you see in the slide it's called. I'm gonna scroll down to the slide. This type of conversion. Let me go back, go back, go back. So this kind of conversion is called automatic conversion, because as you can see, you're converting from a smaller data type, from a smaller byte to a bigger one, and that's not a problem. It will just take it. So let's see if that will work. System.out.print int data. So when we run this now, you see it still prints 124, but this time it's an integer value. And the same thing, we can also make it a double, what's even higher, double, and it would also fit because a double is way bigger than a byte. So when we run this, it will still print 124, but this time puts the stuff there. But what if we wanted to convert from a lower number to a higher number? So take for example, we say we have no, we change this to an int, and we want to So this is our int data. No, let me not just, let's not complicate it. Let's just take this and we put it here and we say this is 1, 2, 4, 5, or 1, 2, 3, 4, and we want to store it in the int data. So we're taking something big now, we want to store it in something small, and you see it's saying, I'm sorry, we cannot do that, right? But it's still possible. And how do you do that? We do that using casting, which is something I've seen a lot of you guys do already. So you take the value and you say, I want you to cast it, even though you don't want to, but do it anyway. Cast this value inside a byte. So you're saying, take this int, press it, spill the water if you have to spill it. I don't care. Put it in a byte. So of course, what will happen is it's going to spill out some. You're going to lose data, and it's going to store here. So even with byte is a lot weirder. You're going to get what lot weirder response. So we see now that it's printing. Sorry, I have to print this guy. I have to print this guy out, and you see it's printing minus 46. Is because it's trying to compress the double data into bytes, and it just doesn't fit, and based on the calculation it does, it returns minus 24, so it doesn't fit. um, but let's also try to compress. Let's see, what if I this was an integer. What if this was an integer and this was a double, and we make this double 5, make this like this, an F, no, D, I think. It doesn't really matter. And then we say we want to convert this to an int. So this is just call this data. So guys, uh, data converted. Let's use some more generic names. So what what do you guys think will be printed? Will this stuff print? So we have a double. So this is a double, so we can look at the double. The double is quite large, it's quite big. So let's go back to the slide and see what kind of value double holds. Let me just pick it up again. So we see a double holds 8 bytes, and int holds 4 bytes. That means it's quite longer, and also it holds fraction numbers. Huh? It holds fraction numbers. So fraction numbers means decimals. It's holding these decimals. So if I took this double and I pressed it into this int, what do you guys think would be the output, or what will happen? Raise your hand, please, if you think you know what. All right. If I can you also give it a try? Exactly. So what you see here, you see the first part is actually a whole number.
The
So, and we
decimal
see
points
that
will
the
be removed,
integer
like it will compress
stores
it to one,
whole
two, three, four.
numbers. It doesn't store decimals. So this first part, 1, 2, 3, 4, it fits in an integer of quite all right, because an integer holds over 2 billion, can hold over 2 billion numbers, like as you can see here. So it can perfectly fit into an integer. But an integer has no business with decimals. So when you typecast it, it's just gonna throw away all of this. So let's run it, and you see that's exactly what it did. So you actually lose data. So you have to be very careful when you're converting data. If you're converting, if for example this was money now, this was money you're calculating, and you took your money that you calculated and you now store it in an convert it to an int, you have actually lost some money for people in your calculation. So that means imagine doing this a million times. That means you've probably lost so much money for people and your calculations will be wrong. And if it was a banking application, your people's bank accounts will constantly be wrong because you keep removing their cents or their kobos or however you want to call it, or the extra change that's or extra decimals that is attached to their currency or to their balance, right? Goswi has a question.
Okay, my question is this.
let's say you want to reduce
What
your
is something
figure
lower?
to
Okay, you mean a type
something
that is
lower
lower,
and still
right?
retain those decimals
So
after.
a
Is
data
it
type.
possible you
So
do that?
what is the
And
lower
if
data
possible,
type
how do you do
compared
that?
to in the same realm as double? What other data type holds floating points? When you
Yeah,
hear the
yeah,
word
yeah.
floating point means decimals. What other data type holds floating points but is smaller than double? Then if you look at our chart, all of this you can look at it on the internet anyway. The, so you see, float is the one that is smaller than double but also holds floating points or holds fraction. You see, a float data type holds 4 bytes while double holds 8 bytes. So of course you can convert from double to float and still retain your decimals as long as your decimals is not longer than 7 digits. If your decimal is longer than 7 digits, you will lose those extra digits because a double digit holds 15. So if you have 15 decimals and you take that 15 decimals that is in a double and try to compress it into a float, you will lose anything after the seventh decimal digit. So in this case, if we change this now to a float and uh, we cast this to a float, let's see, I think so. If we did something like this, we see we get exactly the same result. But let's try something else. Let's try, let me see, how many is this? So we know a double holds 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if we did something like this now and we run it, you see, let's see, what does it do? So you see 1, 2, 3, 4, 5, 6, 7, 8. Sufficient science hexadecimal. So you see, it doesn't even. I think this stuff is even wrong. So you see, it clips it at from this point. So it doesn't return because the double is holding way more digits. The floating point just snaps it to this to it just chops it off. You understand? Because it cannot hold this much decimal points. So of course you can take from double to float because you're actually taking something big and you're trying to stuff it into something small, but you will still retain your decimal points, but you will still lose data. So why am I saying this? When you're doing type conversion, you have to know, okay, if especially if you have to do with numbers, check, are you going to lose data or not? Does it matter if I lose data? If it is the other way around, then it's not a problem. If you had a float and you're compressing into a double, it's not a problem because a double is like a drum, a float is like a cup. You can take what's in a cup and put in a drum and it will hold it. There's no problem. So type conversion downwards is always not a problem. It holds because the data type is large enough, and the other way is a little bit problematic. There's also another type conversion you guys have been playing around with a lot, but I have to also let you guys, we also have to talk about it explicitly, which is conversion from one data type to like to a string data type to a different data type, right? So I see, for example, when you guys get input from the user, you convert it to int. So I see you guys use parse int. Some of you use parse int. Some of you use um, casting. So that's also something we can take a look at. So if I had a string, if I had a string, I'll call this val, and the string is string 5. So sure, I can convert this to an integer. So I'll call this an int, data converted. And so there are two ways I can convert this. One of the ways I've seen you guys do this is using casting and then val, which ordinarily, let me see. Okay, it's not working here. That's correct. Let me see. In this situation, it's not working. I would have thought you could cast it. Okay, so I'm wrong. You cannot use typecasting in this scenario. What I think you could use. Oh, I thought you could use that before. Okay, my bad. What you could use is using the parse int, I think. So this is a string. Let me see. Parse. Okay. Oh, sorry. I think I got that wrong. That is actually going to be something like this: string dot parse. Okay, now I'm totally wrong. Let me see. What's that value of? Hmm. Oh, no, 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 no. I am totally wrong. My bad. I actually even put it in my slide. We actually use value of. So that's string dot value of and val. Now I'm totally wrong again. Let me see. What am I doing wrong here? Okay, no, this is converting to string. That's not correct. I am totally confused. This is what I'm doing it the other way around. So we have an integer here, a type integer, and I want to convert to int. So there's no way I'll be converting with to int with string. So that is my mistake. So we have this 5 here. We want to convert it to int, so we should be converting using the integer dot parse int dot parse int. So that's where I was getting it all messed up because we are trying to convert to an int here. So we're going to put our val here and then run it, and it would run. Now, when you want to convert a number, so I'll say int number a. So if we have a number and we want to convert the number to a string, so that's different then. Then we can do something like this. So I'm just going to duplicate it. Then we can say string, sorry, then we can say string dot capital string dot value of. Then we can now put number a here. And this will convert a number to a string for us or not. Oh, sorry, I have to take this to string. And when we run it now, we see it gives us 56. But this 56 is a string, not a number. So what do you guys think will happen? So let me get rid of this. So I have a value here, which is a string, and I convert it to an integer. So I run this, and it converted properly. It's a 5. It takes the string, it converts it. But what if I did something like this? So what's gonna happen? Constance, what do you think is gonna happen? Okay. Um, so what do you think is gonna happen?
Error.
All right, let's run it and see. Good. Of course, it gives an error. It says
Um,
exception. Let's see if we can read the error. It
I think
says
an error.
number format exception for input string. So why is it this works? Why is it this one is working and the other one is not working? Sumbo, can you tell us why do you think that's why do you think this is working when I put 56 it's working, but when I put something like 56 DFG or whatever it will give me an error? Sorry, come again?
Because integer takes numbers and
Exactly.
not
So that means when you are excuse me, that
because
means when you're
integer takes
converting anything you
numbers,
think is string
not
to an integer to or to any
alphabets
other
or
data type,
letters.
you have to be sure that that string will always hold a number. Remember, you have to be sure. Because if the person types something else other than the data type you're expecting, if it is a string in this case, the person types in a letter, it will create an error for you. And that's not what you want to have in your program. So, but it's possible, as you can see, we can convert a number to a string. Who can tell us a way to that's going to help us not like in order for our system not to crash. How can we make this code not crash in such a way that if I run this code now, instead of it giving us this error, it will just give us a nice message that says this number or this value is not a a valid number. How can we do it? Who's gonna help us out? Okay, if I help us out, you're gonna tell me what to type, and I will type. So what do I do? Tell me. Just tell me exactly what you want me to do, and I'll type it. Okay, where? You have to tell
I
me.
will put
You
the
have to tell me
code
where,
in
what
the try
line,
catch
what
block.
line number.
Try
I know.
the crawly braces,
I
then
I know, but you
catch
have to
your
dictate
exception.
it to me. I'm your student now, so tell me what to do.
You're going to wrap
Tell me what line number.
the whole block inside the whole code inside the main method.
Okay, line number 10. I have to cut it. Okay, cut. All right.
Okay, let's cut cut
Try.
from line number 10 to line number 15.
Okay.
Yeah,
Double cross the base. Okay.
just try crawly
Catch.
braces.
I type exception.
Double.
You want me to type
Yeah. Then I will also put my catch, like catch, then your exception.
okay, number.
Yeah, I think,
Oh, okay, number.
uh,
Okay, I
look,
should select this
like
one. Okay.
IntelliJ number format exception.
So I just
No, I
call
think IntelliJ
E.
brought it
Okay.
out. Yeah, yeah, number
All
format.
right.
Yeah, then you give
Okay.
it
So I
the
should
like the
just do
variable name.
system.out.print
Anyway,
invalid data. Is that okay?
your crawl braces, then you print out the message. Like,
Okay, I'll print out the E. How do I print? I just type E. Okay. All right.
yeah, or you can also print out the E.
I'll put it in this bracket. Okay. I just paste.
Yes.
All right. Let's see what this does.
And then in your try, you paste the
Ah.
code cuts area.
So you see,
Yeah.
thank you, Ifine. That actually solves the problem. So instead of giving us an error now, it just prints out number format exception. What I like to do is, a user normally does not understand what this means. I like to give a more user-friendly error. I'll say invalid number. Please try again. So when I run this now, you see it's going to say invalid number. Please try again. But if this number was a valid number, if this string was a valid conversion, when I run it, it's just gonna convert and not give us the error. Sumba has a question. So I think Sumba is asking
Yeah.
about
This try and
the
catch that was
exception
used, is it
type
the same
that
as the
she
IOE
uses when she's getting
IO
input from
exception?
the user, right? So let me see if we can find one of your assignments. So you mean this one, right? IO exception. Okay, good. So we can see that this buffer reader that we normally or a lot of you use to get input from the user. Let me clean this up a bit. It also puts
Yes.
um, the buffer reader, the read line in a try catch block. And she's asking, okay, is it the same as this? Yes, the try catch is the same. The try catch block, you always hear people refer to it as the try catch block. The try catch block is used to catch exception or catch error, right? Especially runtime errors, right? And we're going to see what runtimes error are as we go on, but it's just take it simple. It's used to catch error. But there are different types of exceptions. There are different types of errors. Exceptions is another word for error. There are different types of error that are programmed in Java for you to catch or to trap if it happens. And one of them is this IO exception. And the IO exception is only will be caught if a buffer reader IO exception occurs. But if you take this IO exception now, if we copy this IO exception and we put it inside, instead of this number format exception, we put it in here, it will not solve any problem. It will not work because the kind of error that would happen here is not an IO exception. The kind of problem that will happen here is called a number format exception. But sometimes you might not even know the name of the exception. An alternative you can use is just type exception. Exception catches all types of exception. Doesn't matter if it is an IO exception, number format exception, whatever kind of exception. This is actually the grandfather of all kinds of exception. Now, if I if we go to the internet, I'll just show you guys a sneak peek of the exception tree. So I'll say Java exception tree. Let's see how it looks like. So I'm gonna open image so you guys will see how a Java exception tree looks like. So I just want to pick out these are all good, but I just want to pick out one that you guys can follow really well. Oh, let me see. There's the image here. So take a look at this image. So this is what you call an exception tree. So remember, I used exception and I told you it's the grandfather of all exceptions, right? So this exception, all other exceptions inherit from it. They are part of it. It's actually the one that gave birth to all other exceptions. That's how you have to look at it. I want to use terms that you can relate to it. So we just used number format exception, which is down here, to catch a specific kind of problem where we're trying to convert a string to a number and that didn't work and we caught it. So you see it's down here. So you might be writing code and you're like, oh, I can't remember the name of this exception. I can't remember the name format number format exception. If you just use exception, it will catch it because as you can see, exception is the grandparent of all exceptions. Then we also have other exceptions like runtime exception, IO exception, no pointer exception, illegal argument exception, and even this IO exception that we looked at. So if we type exception here, except let me see if it will. So you see, exception also works because, like I said, exception is the grandfather of all types of exception. So even the IO exception, even though it was not explicitly, yeah, look at it here. Yeah, this is the IO exception. So the IO exception also inherits from exception. So all exceptions uh, in Java inherit from exception. So that's why if you use exception, it will still work. But normally, you are being advised to use if you know the exception that could occur within your code, it's better you use that exception class instead, so that when someone is reading your code or if it's giving an error, it will print out an error that is related to whatever exception happened. So yeah, try catch block is always the same. The exceptions are different, but if you don't know the name of a certain kind of exception or you don't know what to put there, just put exception, and it will catch any type of exception that occurs within that code. Does that answer your question, Sumba? All right. So I hope I didn't confuse you guys too much on this. So the point is you can always convert different data types within each other, and Java gives you guys the opportunity
Yes.
to do that. So I would like to start winding down. I really thought I could push you guys into arrays, but arrays is going to be something we're going to start playing with very soon. So probably we'll do that next week because I want you guys to come into arrays fresh because that things are going to start getting really exciting when we get into arrays. But for now, uh, we are almost getting through our ABCs. Like I said, I'm happy you guys are playing with it. You guys are getting to it, are getting used to it. And one of the last part we have to discuss is this arrays. And after we're done with arrays, then we start discussing objects and we start progressing into object-oriented programming. That's when we can now start building with what we have learned. We now start, if I compare it back to languages, we now start learning to sing songs. Like, if you learn a language, okay, now I know all these words. Now what can I do with it? You now start learning to make big sentences using big vocabularies, maybe singing a small song. I consider object-oriented programming that. We have learned all this basic. We're learning all these little little things. We've done logical operators. We've done conversions. We've done data types. Everything is going to soon start coming together. But definitely one we cannot miss, which will start next week, is arrays. Arrays is one of the most powerful data structure type that exists in Java, and it's very important you know about it and you know how it works. But unfortunately, we're going to do that next week. So I have beautiful assignments for you guys, which I'm going to post on the chat. This one has to do with the modulo, and I would do this. Let's do this together. We have a few minutes. I'm gonna do this together with you guys because I promised to show you guys what modulo can do, and I have other assignments for you guys that you can also solve. Let me see. Yeah, no. Let's go back. Yeah. So yeah, I think it's gonna be a fun time. Fun stuff to do. So let's go. Yeah. So this is probably easy for a lot of you guys. Let me get rid of this so I don't give you guys too much hints. Or maybe I give you guys a hint on this one. So if I told you to write a program and you should loop through the code 1 to 20 and only print out the odd numbers, how would you do that? If I say write, if I say write, let me just put here, write a program that loops through number 1 to 20 and print out the odd numbers. So who can help us out? Let's solve this together. How are we gonna do this? So everybody's gonna give a piece of code. So what do I type first? And I'll listen to you guys, and you guys will tell me what to do, and I will type. Again, we want to loop through the numbers 1 to 20 and print out only the odd numbers that we find between numbers 1 to 20. So if you're gonna start, tell me the first thing to type, and then you stop. Dictate. You have to dictate our type. If you don't know, you can say skip. Okay. We I'm gonna type we need
All right.
a for loop. Okay.
Can I start with comments? Like, look, we need a for loop. Yeah, a for loop
Yeah. Okay. And print the
through loop.
no. You have to print the odd numbers.
Maybe
Yeah.
like a for loop to
So
loop through 20 times.
what do I do?
Like a number from 1 to 20, right? And print the
Okay.
even numbers. Okay.
For int I. Okay.
Odd numbers. Okay. A for
Okay.
loop. The
One. All
for,
right.
then int I.
So if I is less than 20,
Like
okay, less
assign
than equal to
1
20,
to it. Then if I is less than 20,
increment I. All right, thank you. Ifeanyi has given us a block to start with.
less than or equals to
Who's
20,
next? Who wants to volunteer to go next?
then I plus plus.
Who's gonna volunteer? So if I give us a good startup, remember the question is I want to loop through 1 to 20, and we already did the for loop. This is a very beautiful way to count from 1 to 3 to 20. But I'm only looking for odd numbers. Constance, you want to try? I want to print only odd numbers. Okay, just int. Okay, int what?
Okay.
So tell me again.
So I think we need
The
a variable.
num. Okay.
So
Num
int
is one.
num
Okay.
um is one. Num is one.
Num
Int number
plus
is
equals.
one.
Okay.
And then I'm thinking, okay, num plus or is equals to wait, 1 second. Um wait, that doesn't make sense, does it? Num plus is equals to
Yeah, but it's already increasing here
I.
every time.
Wait, that doesn't make any sense, does it?
Okay. Num plus plus. All right.
Uh I want the number to like keep increasing every time you okay, where? Num plus plus.
Okay.
Num plus plus. Sorry. Yeah. And
What if statement?
then
Oh, if num. Okay.
and then
If I.
if in the if statements, or you need to put a
Mhm.
semicolon after that, I think. And
Modular
then I think
sign.
we need the if statements. And then if num is
Okay.
no, if I and then the modular sign, num print odd number. Wait, what? If
Oh, I have to put is true.
wait,
True.
if I modulus
Oh,
num
okay. Print. So that.
is
No, it's good. You tried. This is good.
true.
This is good. I have to print
Yeah, I'm
odd
done.
number.
That's all I can
Odd
think of.
number.
It's
Okay.
true, yeah. Then
Well,
print
it's not really
odd
working
number.
because
Okay, never
yeah.
mind. Um,
Okay.
if I modulus num is true, we need to create, yeah. Oh, we need to create a boolean first,
So I have to put a boolean here.
saying okay, cool. Boolean
Okay. Boolean. Odd
is
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 what?
is odd is
True. Okay.
no, probably after, yeah, that
Do you
there.
know why this is giving you error here? Maybe we have to solve this first.
True.
So this is giving error because the evaluation of this two does not ever give you a boolean. The evaluation of this two gives you a number. Remember, a module returns a number. It doesn't return a
If
boolean.
I
So probably
modulus.
that's why this is giving you an error. But then you have another problem because this just gives you an this
Oh
just gives you an
yeah.
answer, and the if statement is looking for a boolean. Is looking for something that when you evaluate it is going to return a boolean. All right, but good try, good try. We keep that in mind.
First.
So,
Okay.
but it's good. Like that's how you learn programming. You have to bash your head on the wall a bit, and you'll be like, oh my god, this doesn't make sense. Oh my, wow. All
Right.
right, let's try someone else. Chino, so go.
It's okay.
Okay.
Okay. Oh,
Okay, so since we are looking for
Modulo. Okay.
the even numbers, so you can
Mhm.
do if
Yeah, you have to tell me exactly what to
I
type.
is then modular divided then two. So that will give us the answer. Okay, yeah, then two then think um if I it's if any of the I number divided by two, then to give us we'll be sure that that is an
Hey, it's coming together. It's coming
even
together. You
number.
guys are bringing
So
ideas
to
to the table.
remove that,
Sumbo. Okay, Sumbo is not behind the computer at the moment. Gosu, you
I
want to give it a try? Let's try. Everybody has
think
a
I'm
piece of
stuck.
the answer in their own, so it's very good. I like what's going on. Gosu, do you have a proposition? Okay. All right, let's go back to Ifine because I think Ifine you would know how this. Ifine, help us out. You have to tell me
I
what to
have no
do.
idea. Serious.
Okay, if I modulus 2
All right, in
is
the if
equal
statement,
to 0.
we have an if statement. Like if I
Yeah.
modulus 2 is
Oh,
equals
okay.
equals to
It's
0.
not equal. Oh, I see. Okay, okay. Let's go. Then what?
No, we're looking for odd numbers, right? Not equals to 0. Like the not.
All right. So this is the answer actually. So let's run that and you see what it's gonna do.
Then we
So you
print the
see it's
print
printing
I
all the
system dot
numbers
out dot prints
that are
ln
not
I.
um that are not even. And let's look at this again. Let me break it down again. If you look at it now, it's gonna make total sense to you. So remember, anything you evaluate within an if statement, an if bracket has to always return a true or a false. So what we are doing here is we are saying take when you are looping for every number you loop, check if you divide that number by 2, does it have any remainder? And how do you check if something does not have any remainder? I mean, how do you check if something has a remainder? That thing has to be greater than 0. Anything that has a remainder that is greater than 0, that means that value has a remainder when you divide it. So in this case, when you say 1, it starts with 1, right? 1 divided by 2, if you modulo that, the remainder is greater than 1. It goes to 2. When it goes to 2, 2 divided by 2 has no remainder, so it doesn't print this. 3 divided by 2, the remainder is 1, so that means it's not equal to 0, then it prints 1. Uh, so yeah, so that's actually what is happening here. And you see, when you evaluate this expression, it returns either a true or false. When it returns a true, it goes in here. When it returns a false, it comes out, it doesn't do anything. Does that make sense? So this is how you can use modulo to find even odd numbers. So how can we just twist this now real quick to search for to print out only even numbers? Just tell me what to change because we already have it here. But what can we change now to print out only the even numbers? So let's go with constants again. Let's run this. And you see that's exactly what's going on here. So you have 2, 4, 6, 8, 10, 12, 13,
Remove
14, 15,
the
20.
instead of
Because we are
the
actually saying for every number
exclamation
you get,
point,
if you
put
divide it by 2
is
and the answer
0
is 0, once the division of
equals to 0.
a number by 2 returns 0, it means that number is an even number. So you just print the number out for us, which is the I. Right? So you see, this is a very interesting thing modulo does. Let me just do one more. So if I have a number here, let me teach you guys this one. I just learned this one too recently. So if I had an integer of number, I just got this number, and I type, let's do this, and I want you to, how do I print the last digit of any given number? So print the last digit of this of this variable of the number variable. So does anyone know how I can print the last digit? All I want is any number I put in this variable, just give me it. I just want you to just give me the last digit. Does anyone know how to do that? Constance, Chinonso, go. So in what case? In this case, you mean I
Um,
should
the
do
only thing I can think of is
number
number
one, two,
dot
0, 1, 2, 3,
then
4, 5, 6. Number 6, like this.
the
Number
position of the
6
number, but I don't think that will work. I
dot
don't think that's what you're looking for.
6.
Zero.
No, that wouldn't work. And even if this would work, this it would never work anyway. But just
Yeah.
think about it logically. Even if this would work,
Your
work,
number
what if
dot
I added more number? That means you have to still come here now and change it again.
6.
But I want you to just give me the last number, and regardless of the
That would
length,
work.
doesn't matter how the last, just give me the last number. How would you solve this? Good try. Who has another idea? If I just print 5, yes, or I'll change it now. Print. Let it print 9. Just whatever number is the last number. How'd you do that?
You mean maybe as you have this number, we are going to print 5, right?
Uh, okay. If I has another solution, so I'll just do it out. So
Okay.
if I is saying
I
let's use
don't
a
think the
converter, so we're
int
gonna say
has
string,
a length property, but we convert it
string,
to string,
num,
then
convert.
get the length of the string plus 1.
So if I say okay, I'm going to convert this number to a string. So I'm gonna say number dot I'm gonna say sorry, I'm gonna say string. Remember we did that conversion. String dot value of. So he's converting the number now to string, right? So he has converted the number to string. Then he said he's going to find out what is the length of this string. He's going to find out how many characters are, because now he has converted it to a string. So in here now this number converts. He wants to find how many characters are in this converted string. So how he's going to do that is going to say number of characters. Uh, then of course is an int. He wants to find the number of characters that are in it. In this case now in here, so he's going to do something like num convert dot length, because there's a length property there. So when you do this, you're saying when you do this to a string, it will return to you the number of values that is in the number of characters that is in the string. So in this case, this is synonymous to this now. So now he's now saying he's going to now print system dot out dot print, and he's going to take this string of numbers that has been converted, and he's going to print out the last character. So since he already knows the number of characters that is in it, he's going to take it and put it in an array and do -1, I think. Is that what you want to do? Or maybe not this way, because this is not even working. You're going to change this and make it character at the string -1. And -1 because the number, remember the character starts counting from 0, 1, 2, 3, 4, 5, 6. So when you get the length, you want to get one number less than the length because it actually starts counting from 0, 1, 2, 3. All right, is this what you had in mind? Okay, so if we print, sorry?
Plus 1.
Okay, so if we run this, yes, this gives us 9, which is the last number. So even if we
Yeah,
change this
yes.
now to
Though the screen is
just
a little bit
2, it will give us this.
blurry.
To give us the last. It will give us the
Though
last
my
one. So
screen
this
is a
this is
little
an
bit
interesting way to
blurry,
solve it.
but I can
A
manage.
very interesting way to solve it. But there is even an easier way to solve it, right? So good try. So you see what he did here? He had to convert it. He converted it to a string from a string. That was what Chinonso was trying to do. Chinonso was like, "Oh, I want to get the the index space." But remember, you cannot do that for an integer. You can only do that for a string. So that's why if I converted it to a string so that he can say, okay, I want a character at, which we did here. All right, good. But let me show you guys now an easier way to do it so you can see how many lines of codes we use here. So I'm going to comment all of this out. In fact, I'm just going to push all of this downward. So this works. It's an interesting solution. I'm going to push all of this down. Now let me show you how to do this with modulo. Now there's uh, the interesting thing you guys need to know is whenever you want to find the last character of any integer, if you modulo that character with by 10, it will always give you the last character. I think it's a mathematical thing. You just need to know it. So let's try it. So if we say system.out.print ln and we say number, um, let me see, number modulo 10. So let me spread it out so it's readable for everybody. And this is the answer. Let's try. Maybe I'm screwing it up now. So I'm just gonna change this to 3 and run this. See, it gives you 3. If I change it and I put 8, it gives you 8. If I change it and I give you 7, it gives you 7. If I reduce it to just 2, it gives you 3. So this is a very simple mathematical formula. It has nothing to do with programming. This is just simple, just math. Any number, if you want to find the last number of any digit, divide, get the remainder of that number when you divide it by 10. Any number, just get that number, divide it by 10. The remainder is always the last digit of that number. So if you get these questions in your interviews or anything, it's a one-line solution. That number modulo 10 will always give you the last digit of that number. So who has never seen this before in math or in anywhere? Goes with you too? Ah, now I'm better than goes with math. I'm happy. I'm very happy. So it's a cool trick. But it's just to show you also that this modulo is very powerful. We use it for a lot of things. There's a lot of logical things you want to do. Modulo will just solve it for you. So you see, just a one line code and we're done. That's it for the class today. I hope it was not too confusing. We did a lot of different topics, but very, very essential. I will give you some more exercises that has to do with modulo. So you see here, we're gonna have a leap year check. You guys are gonna do some kind of leap year check. I will leave a hint for you guys to help you guys solve it. So what I want you guys to do is print out leap years or something. Just read the. It's a create a program that checks if a given year is a leap year. So if it's 2000 and if it's a 2000 if you put 2024, you have to check if it's a leap year. And a leap year is a year. The rule for leap year is a year is a leap year if it is divisible by 4. So the formula is already there for you. I also have some more, sum of multiples. So I also left hints for you guys here so you guys can solve it and use the techniques that are needed. I'm also going to add some more. Okay, no, I'm not going to add some more because I have some other assignments, but it's for arrays. But play around with these ones. Um, I think from next week we're going to start dealing with some really interesting stuff. I can't wait to start discussing arrays with you guys because arrays is very powerful, and with arrays we can start really building things. All right. Any questions? Do you guys have any questions? Let me see. Raise your hand if you have questions. If something is not clear. So Chinoso is raising up her hand. All right. So I'm going to paste this assignment because I tend to always forget that. Let me just paste it directly into the chat.
Sorry, that was from
All right,
the
just give me a minute.
previous time.
Do that again. Copy. So let's go to the other ones. Close. Let's try this again. Copy and this one. So yeah, please do your assignments. Yeah, if I it's also good you are following the assignment, even though they might be very easy. It's very important. It also gets you acquainted with the code. Guys, please do your assignment. This is how you learn. You learn by doing. You learn by practicing. And I wish you guys have a very pleasant weekend. I'm always happy to have these classes with you guys. I always look forward to giving it. And what is even more exciting is I'm really seeing that you guys are really like programming now. You guys are writing stuff. You guys are really thinking. That's really exciting for me. And I'm really going to do my best to, like I said, my goal is to usher you guys into getting a job with this and stuff. And also, yeah, I let you guys. I also showed you guys an exam, a Java exam that would be really nice for you guys to take. I would really be very happy if one or if not all of you take that Java exam. That will be your entrance. That would be like when you do that, you can put that in your CV, and yeah, you can use it to look for a job. I have taken a couple of exams. I've taken so many exams. Even yesterday, I took another exam, a Microsoft exam. So I'll show you guys my let me show you guys my LinkedIn account. So you can see on LinkedIn, if you scroll all the way down, you see all my certifications. I have I have one, two, three, four, I think what? Yeah?